Tonight, we journey to some of the most extreme places on Earth. The extraordinary polar ice caps. In these frozen realms, mountains and oceans hide beneath miles of ice, and the air itself glows with green and violet auroras. Here, the familiar rules of the world begin to bend. Time seems slower, sound carries farther, and in the stillness, the planet reveals its oldest secrets. Stories written in snowflakes, carved in glaciers, and sung by creatures who have never known the feeling of warm air. The poles are more than cold. They are memory, mystery, and motion, the living heartbeat of a planet in balance. Before we begin, if you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought in the comments. It helps others find their way here too, one sleepy soul at a time. For now, just breathe. Let your eyes grow heavy, and let the hush of the polar winds carry you far from the noise of the world. Let's begin. Antarctica holds nearly 2/3 of all Earth's fresh water, locked away in ice. At the bottom of the world lies a vast frozen reservoir, the Antarctic continent, cloaked in a blanket of ice up to several kilometers thick. Within that ice lies nearly 2/3 of all the fresh water on Earth. Every snowflake that falls there becomes part of an ancient archive, pressed into the layers that form mountains of frozen time. If all of Antarctica's ice were to melt, sea levels would rise by roughly 60 meters, flooding coastlines across the planet. Yet most of that ice never melts at all. It simply flows, slowly and silently, like a solid river toward the sea. Beneath it, hidden valleys and buried lakes have not seen sunlight for millions of years. Antarctica is not simply frozen, it is breathing, shifting, and storing the memory of Earth's water, waiting in a stillness so deep that centuries pass like single moments. The Antarctic ice sheet is so heavy it pushes the continent's crust downward. The ice of Antarctica is so unimaginably heavy that it bends the Earth itself. Spread over more than 13 million square kilometers, it weighs enough to push the rocky crust beneath it downward by hundreds of meters. The ground there is not solid and unyielding. It moves, ever so slowly, under the pressure of the ice's weight. When glaciers thin and retreat, the land begins to rise again, rebounding like a cushion released from strain. Scientists can measure this rebound using satellites, watching the crust lift by millimeters each year as the ice above changes. It is a reminder that even stone and continent are flexible when viewed on the timescale of the planet. Antarctica is not a frozen still life, but a dynamic system of gravity, weight, and motion. An immense hand pressing upon the Earth, shaping its surface as gently and relentlessly as the tides shape the sea. Greenland's ice is thick enough to bury Mount Everest beneath frozen layers. Greenland's ice sheet, a gleaming expanse of white and pale blue, holds more than enough frozen water to reshape the world. In places, that ice is over 3 kilometers thick, enough to bury the height of Mount Everest beneath its surface. Beneath the ice lies a hidden landscape of mountains, valleys, and even long-lost rivers, carved by ancient flows of water and then sealed away. The pressure within the sheet is immense at its base. The ice behaves almost like a fluid, moving slowly outward toward the ocean. Scientists drill deep into the Greenland ice to study how it has grown and melted over the ages, tracing the delicate balance that determines sea level worldwide. Though it seems timeless, the ice is always in motion, a vast, frozen ocean flowing at the pace of centuries, powerful enough to reshape the land, yet fragile enough to vanish under a warmer sky. The East Antarctic Plateau is the coldest place on Earth, reaching -100 degrees Celsius. At the top of the East Antarctic Plateau, the air is so cold and dry that even the faintest moisture crystallizes instantly. On windless nights, under skies filled with stars, the temperature can fall below -100 degrees Celsius, colder than dry ice, colder than anywhere else on the planet. At such extremes, metal becomes brittle, plastic shatters, and human breath freezes into tiny clouds of ice dust. Yet in that emptiness lies profound stillness. The snow there has lain undisturbed for centuries, shaped only by the whisper of wind and the faint light of the moon. Satellite sensors have pinpointed these frozen hollows, recording the planet's ultimate chill. It is the place where heat itself seems to flee the Earth, radiating upward into space. To stand there, if one could endure it, would be to feel the edge of habitability, the absolute silence of a world in pause. Arctic sea ice grows and shrinks with the seasons, doubling in winter. The Arctic Ocean is alive with rhythm. Each year, as sunlight fades and the long winter settles in, the sea begins to freeze. Inch by inch, floes expand outward until the ice covers millions of square kilometers, nearly doubling its summer extent. Then, with the return of spring, the sun warms the surface, and the ice retreats, cracking into drifting mosaics of blue water and white shards. This breathing cycle of freeze and thaw shapes the lives of every creature that calls the Arctic home. Polar bears follow the edge of the ice to hunt. Seals rest upon its surface to give birth. Even microscopic algae grow within it, feeding entire food webs. From orbit, satellites watch this seasonal heartbeat, a pulse of frozen light expanding and contracting each year. Though fragile and fleeting, it is one of Earth's most elegant natural rhythms, a planet's breath made visible in ice. Icebergs calving from glaciers can be larger than entire cities. When a glacier meets the sea, the edge begins to crack. Pressure builds silently for years, until at last the ice gives way, and a piece the size of a city breaks free. The moment of calving can shake the air like thunder, a deep groan that echoes across the water. The newborn iceberg drifts out into the ocean, shimmering with impossible blues. Some are vast enough to have their own weather, fog forming above them, snow falling upon their peaks. Over time, the sea sculpts their towers and arches, carving tunnels through translucent walls. Eventually, they melt into the water that first birthed them, returning their frozen memory to the sea. Each iceberg is temporary and eternal at once, a floating fragment of a continent, a monument to cold, and a reminder that even the largest structures on Earth are only ever passing through. Some Antarctic icebergs have drifted for more than 20 years. An iceberg's life does not always end quickly. The largest ones, tabular giants that break from Antarctica's ice shelves, can drift through the Southern Ocean for decades. Caught in slow-moving currents, they travel thousands of kilometers, passing through fog, storm, and sunlight. Satellites have tracked some of these icebergs for more than 20 years, watching them shrink, fracture, and reform. Along the way, they reshape ecosystems. Their meltwater releases nutrients that feed plankton blooms, drawing whales and fish in great numbers. When they finally vanish, it is as quietly as they began, melting into the endless blue. Each long-lived iceberg is a voyager, carrying ancient snow into new waters, spreading the memory of frozen ages across the seas. They are the drifting ghosts of Antarctica, luminous, impermanent, and as graceful in death as they were in their icy birth. The underside of icebergs glows with surreal shades of blue and green. Beneath the surface of the sea, the hidden faces of icebergs reveal colors that seem almost otherworldly. The deeper the ice, the greater the pressure, and the fewer air bubbles it contains. When sunlight filters through, those trapped layers scatter light into brilliant shades of blue and green. Some glow like glass lit from within. Others appear streaked with jade or turquoise veins. These colors tell stories of origin, the pure blue ice formed from compacted snow, and the greener tones born where seawater once froze into the glacier's base. Divers who venture close describe it as floating inside a crystal cathedral, where every surface shimmers and hums with shifting light. The iceberg, for all its mass, becomes weightless and alive in those colors. It is one of nature's quietest miracles. Sunlight, salt water, and ancient ice collaborating to paint the sea from beneath. Multi-year Arctic sea ice can be over 5 meters thick, ancient and resilient. Not all sea ice melts each summer. Some survives the thaw, year after year, compressing and strengthening as it endures. This multi-year ice becomes dense and deeply ridged, often exceeding 5 meters in thickness. It moves slowly through the Arctic Ocean, carried by wind and current, growing ever tougher as new layers freeze atop the old. Its surface is rough and blue-white, carved by storms into ridges and hollows. Beneath, it shelters an entire hidden world. Algae cling to its underside, feeding tiny crustaceans that in turn feed fish and seals. Scientists study multi-year ice as a record of persistence. It reveals how long the Arctic has been breathing in and out, freezing and melting through centuries. But this ancient ice is vanishing fast. In a warming world, its strongholds are shrinking, leaving behind younger, thinner ice that cannot remember the winters of the past. Antarctic ice traps, bubbles of ancient air from hundreds of thousands of years ago. Each layer of Antarctic snow begins as a whisper of atmosphere, falling gently through the cold. As more snow piles above, the pressure compresses the lower layers, sealing tiny bubbles of air inside. These bubbles are perfect time capsules, pockets of ancient atmosphere, untouched since the moment they were trapped. When scientists extract them from deep ice cores, they can measure the composition of air that humans have never breathed, the levels of carbon dioxide, methane, and oxygen from hundreds of thousands of years ago. These samples reveal how the planet's atmosphere has changed, how warm periods came and went, and how delicately balanced our climate truly is. To hold such a fragment of air is to touch time itself, to inhale a whisper from a world before cities, before language, before memory. Inside every frozen bubble, the past is still breathing softly. Antarctic ice cores reveal a climate record stretching back 800,000 years. Deep within Antarctica's frozen interior, scientists drill into ice that has not felt warmth for nearly 1 million years. Each layer they extract is a page in Earth's frozen diary. Snow that fell, compressed, and turned to ice over countless seasons. Trapped within these layers are air bubbles, dust, and chemical traces from ages long gone. Together, they reveal a rhythm of ice ages and thaws, of quiet stability interrupted by sudden shifts. By studying these cores, scientists can reconstruct the composition of the atmosphere across 800,000 years, tracing the rise and fall of carbon dioxide and methane as our planet breathed through time. These patterns show that climate has never been still. It has pulsed, cycled, and evolved in tune with orbit and sunlight. In this icy archive, the past still speaks, a whisper of wind, preserved in glassy silence beneath the Antarctic sky. The deepest ice cores show volcanic eruptions and cosmic dust in ancient snow. When the deepest ice cores are lifted from the Antarctic crust, they reveal far more than snow. Within their layers lie streaks of volcanic ash, dark, delicate threads left by eruptions that once dimmed the sun and changed the course of seasons. Some layers glimmer with particles not from Earth at all, microscopic grains of cosmic dust. the remnants of meteor trails that drifted through our atmosphere and came to rest in frozen drifts. These fragments record both fire and starlight, the dual stories of a restless Earth and a vast, glittering cosmos. By reading the ice's chemical signals, scientists can tell when volcanoes darkened skies or when distant celestial events brushed against our world. Each flake of ash, each cosmic mote, is a punctuation mark in Earth's long narrative. Proof that even at the frozen ends of the planet, the universe is always touching down. Oxygen isotopes in polar ice reveal patterns of past ice ages. Hidden in each snowflake is a chemical fingerprint. Oxygen atoms exist in slightly different forms, some lighter, some heavier, and the balance between them shifts with temperature. As snow accumulates and freezes, it locks those isotope ratios into place. By measuring the ratio of oxygen isotopes in ancient ice, scientists can reconstruct the temperature of Earth's past with extraordinary precision. The pattern that emerges is a waveform of deep time, the steady rise and fall of ice ages, their slow crescendos and sudden retreats. These isotopes reveal that the planet has always moved in rhythm with its orbit and tilt, the sun's light varying just enough to tip the balance between frost and thaw. Through this frozen chemistry, we can see not just what the world once was, but how sensitive it has always been. A living system that listens, breathes, and remembers. Traces of Roman era lead pollution are preserved in Greenland ice. In Greenland's ancient ice, scientists have found one of humanity's earliest fingerprints, thin layers laced with lead that fell from the skies 2,000 years ago. The source was not industry as we know it, but the smelting furnaces of the Roman Empire, burning ore to mint coins and craft pipes. The smoke drifted high, crossing oceans and continents before settling softly over the Arctic. Each rise and fall in lead concentration mirrors the fortunes of Rome itself. Prosperity, decline, war, and plague, all written as faint chemical echoes in the snow. The ice kept this story long after stone walls crumbled and empires faded. It shows that even in the ancient world, our actions reached far beyond what anyone could see. Human history, in its triumph and turbulence, left its trace not just in ruins and books, but in the quiet memory of Greenland's frozen sky. Microscopic pollen from faraway continents lies frozen in polar layers. Sometimes, the wind carries the smallest travelers to the farthest places. Tiny grains of pollen, released from distant forests and fields, drift upward until they are caught in high-altitude currents. They circle the globe for weeks before descending in snow at the edges of the world. There they are entombed, preserved perfectly in ice. Under a microscope, each grain reveals its origin: a pine from Siberia, a grass from Canada, a flower from an age long past. By mapping where these travelers landed and when, scientists can trace ancient wind patterns and even the pulse of ecosystems thousands of kilometers away. It is a reminder that nothing on Earth is truly isolated. The polar ice holds not only the story of cold, but the faint breath of faraway summers, proof that the winds of our planet have always carried whispers between worlds of green and white. Katabatic winds in Antarctica can roar downhill at 300 kilometers per hour. On the high Antarctic plateau, where air cools until it becomes heavy as stone, gravity takes over. That dense air begins to slide downhill, gathering speed and force as it descends. These are katabatic winds, the most powerful and persistent on Earth. They can reach 300 kilometers per hour, faster than a hurricane, scouring the ice into sharp ridges called sastrugi, and polishing valleys until they shine like glass. Yet these winds are not merely chaos. They are the continent's great breath, redistributing cold air from the interior to the sea and influencing global circulation patterns that affect weather half a world away. For the explorers who have stood against them, the winds are both terror and awe, an invisible river pouring endlessly toward the coast. In the pause after a gale, when silence returns, Antarctica seems to sigh, as if exhaling centuries in a single motion. The South Pole is a desert, drier than the Sahara. It looks like an endless ocean of snow, but the South Pole is, in truth, one of the driest places on Earth. The air there is so cold it can hold almost no moisture, and what little snow falls drifts down as fine, crystalline dust, only a few centimeters a year. Because it never melts, this tiny accumulation builds slowly, creating the illusion of abundance. In reality, Antarctica's heart is a frozen desert, drier even than the sands of the Sahara. The dryness preserves everything it touches. Wooden huts from early explorers remain nearly unchanged, and even footprints can last for decades. Time itself feels slower here, stretched thin by cold and silence. It is a landscape built not by rain or river, but by patience, a desert of frozen light, where the very absence of water has sculpted the most enduring ice on Earth. Arctic storms compile sea ice into ridges several stories high. The Arctic Ocean may appear still, but when the wind rises, it becomes a landscape in motion. Powerful storms sweep across the frozen sea, pushing and breaking the ice until it buckles upward in walls of shattered white. These pressure ridges can climb several stories high and stretch for kilometers, their hidden keels plunging deep below the surface. Each ridge marks a moment of collision, a frozen scar where two vast plates of ice met in slow motion. Beneath their shadows, algae bloom, fish shelter, and seals find protection from predators. To explorers, these ridges are obstacles to the ocean. They are architecture. They grow, collapse, and rebuild with each season, forming a moving mosaic that reflects the ceaseless tension between wind and water. When the storm passes, the ridges stand silent, monuments to the restless strength of a frozen sea that never truly sleeps. Auroras blaze most often in the polar skies. At the world's edge, night itself comes alive. The auroras, born from the sun's restless energy, appear when charged particles race along Earth's magnetic field and collide with atoms high in the atmosphere. In the Arctic and Antarctic, those collisions unfold in vast curtains of green, violet, and crimson light that ripple soundlessly across the sky. Each display is a cosmic conversation, the sun speaking in color and the earth replying in glow. Ancient travelers saw them as spirits, fires, or celestial battles. Modern science calls them magnetic storms. Both truths coexist. They are beauty born of physics, awe born of light. Under an aurora's shimmer, snow turns to liquid silver, and shadows disappear. It is a reminder that the poles are not only cold, they are alive with invisible power, where heaven and earth meet in luminous, dreamlike silence. Polar night brings weeks or months of unbroken darkness. There are places on this planet where the sun sets and does not return for months. During the polar night, the world turns blue and still, lit only by stars and the wandering glow of the aurora. The snow reflects what little light remains, casting a ghostly sheen over the frozen ground. For animals, this endless twilight demands patience and adaptation. Some migrate southward, while others, foxes, seals, and bears, remain, guided by senses beyond sight. For people living under that darkness, time softens its edges. Days blend together, lamps replace daylight, the rhythm of sleep and waking becomes fluid. Yet there is beauty in the absence of the sun, a hush, a deep calm, and a feeling that the earth has paused its turning just long enough to dream. When the first light returns at last, It feels like rebirth, a slow sunrise after an eternal night. The midnight sun shines endlessly through polar summers. When the planet tilts just right, the poles are bathed in daylight that refuses to fade. For weeks or even months, the sun circles the horizon, never setting, never resting. The world glows in perpetual golden twilight, where shadows drift but never disappear. Birds nest without night, flowers bloom in a hurry, and the tundra hums with brief, frantic life. Humans living under the midnight sun learn to sleep by habit, not by darkness, and to measure time by memory rather than light. To stand in this endless day is to feel suspended, neither morning nor evening, but a soft continuum of brightness that seems to stretch outside of time. Yet even this light carries a quiet melancholy, for it is fleeting. Soon the tilt will turn again, and the long night will return. But for a while, the Earth lingers awake beneath a sun that never sleeps. Antarctica holds the record for the coldest temperature ever recorded. On a wind-scoured plateau deep within East Antarctica, instruments once measured a temperature so low it neared the limits of habitability, minus 98 degrees Celsius. At that point, the air itself begins to crystallize, and even carbon dioxide can freeze. Sound travels sluggishly through the dense cold, and human breath turns to powder mid-air. It is a cold so intense that nothing familiar applies. Metal snaps, fuel thickens, and motion slows to reverence. Yet even there, in that absolute silence, life endures in microscopic form. Bacteria in rock pores, algae beneath the snow, waiting for a fraction of warmth. Scientists who work there describe the cold as physical presence, not just temperature, an immense, invisible weight pressing upon the world. In that place, the planet reveals its extremes, showing us what it means to be alive within such a narrow band of warmth between fire and void. Emperor penguins are the only penguins to breed in the Antarctic winter. When the polar night falls and temperatures plummet, emperor penguins begin their cycle of endurance. Thousands gather on the frozen sea, each female laying a single egg before returning to the ocean to feed. The males stay behind, balancing their eggs carefully on their feet, covered by folds of skin to keep them warm. For nearly 2 months, they stand together in howling blizzards, fasting as winds roar across the ice. They huddle close, shifting positions so no penguin faces the cold for long. When at last the chicks hatch, tiny voices fill the darkness, fragile warmth breaking the silence of winter. As the sun returns, the females come back with food, and life resumes its rhythm. The emperor penguin's devotion is unmatched in the animal world, a story of patience, endurance, and quiet love written across a landscape of unyielding cold. Polar bears are marine mammals, spending most of their lives on sea ice. The great white bear is not a creature of land, but of ocean. Classified as a marine mammal, it lives and hunts upon the shifting sea ice of the Arctic, following the rhythm of the frozen tides. Its thick fur and black skin hold heat close, while layers of fat insulate it against the numbing water. It can swim for days at a time, covering vast distances between flows, moving through an environment that never stops changing. On the ice, it waits silently beside seal breathing holes, guided by scent and patience honed through evolution. The sea is its highway, its hunting ground, and its cradle. As the ice retreats, these bears are forced to swim farther, chasing a home that keeps drifting away. Yet for now, they remain symbols of strength and solitude, living bridges between the elements of water, air, and snow. The Arctic fox's fur shifts from brown in summer to white in winter. Few animals wear the seasons as elegantly as the Arctic fox. In summer, its coat darkens to shades of grey and brown, blending with the stone and moss of the tundra. As winter approaches, the transformation begins. Fur thickens, brightens, and turns snow white, rendering the fox almost invisible against the drifts. This seasonal camouflage is more than beauty, it is survival. Beneath the snow, the fox hears the faint rustle of lemmings and dives headfirst to catch them. Its body is built for cold. Even the soles of its paws are furred for warmth and traction. When food is scarce, it scavenges behind polar bears or buries leftovers for later. Through months of darkness and wind, the fox remains alert and graceful, its coat shimmering like frost. It is a creature perfectly tuned to the rhythm of change, the very embodiment of Arctic resilience. Tiny rotifers and nematodes survive frozen for decades. In the permafrost of the Arctic, microscopic life waits. Rotifers and nematodes, creatures smaller than a pinhead, can endure complete freezing by slipping into a suspended state called cryptobiosis. Their cells expel water, and their metabolism halts to near zero. Decades, even centuries, can pass. Then, with the return of moisture and warmth, they awaken, moving, feeding, and reproducing as though no time had gone by. Some revived specimens from Siberian ice have been dated tens of thousands of years old. Their existence is a quiet miracle of endurance, proof that life can pause and resume across epochs. While larger creatures depend on warmth and movement, these tiny survivors wait out eternity. They show that survival isn't always about strength. Sometimes it's about patience, trust, and the ability to become almost nothing until the world turns kindly again. Antarctic ice fish live without hemoglobin. Their blood is nearly transparent. In the icy black waters off Antarctica, there swims a ghost. The Antarctic ice fish carries no red pigment in its blood. It has evolved to live entirely without hemoglobin. Its blood runs clear, moving oxygen directly through plasma, aided by the cold, oxygen-rich sea. Its heart is enormous, its metabolism slow, and its skin thin enough to draw oxygen straight from the water. To survive, it produces natural antifreeze proteins that keep ice crystals from forming inside its veins. These adaptations make the ice fish one of the strangest vertebrates alive, a creature designed for stillness, cold, and lightless depths. Seen under submersible lights, it appears translucent, almost invisible, drifting through a realm few will ever witness. In that alien quiet, it thrives where others cannot, a living symbol of evolution's endless creativity and life's ability to bloom in even the coldest dark. Some Antarctic sponges live for thousands of years. Beneath Antarctica's frozen seas, the water is still, dark, and cold enough to slow time itself. Here, among rocks and sediments, ancient sponges anchor to the seabed, growing so slowly that centuries pass between meaningful changes. Some have been dated at more than 10,000 years old, older than civilization, older than written history. Their bodies filter water so gradually that they become archives of their surroundings, absorbing trace elements from the ocean decade by decade. Though they appear lifeless, these sponges persist through ice ages and shifts of climate, enduring where faster creatures perish. They are monuments of patience, living sculptures of survival. In their silence, they teach a profound truth, that longevity often belongs not to the swift, but to the still, to those who find harmony with time's slow current rather than struggle against it. Weddell seals dive 600 meters and stay submerged for over an hour. The Weddell seal, plump and silver gray, lives among the ice floes of Antarctica's coasts. When it dives, it does so with a calm mastery that borders on serene, descending to depths of 600 meters and remaining underwater for more than an hour without surfacing. Its blood carries extraordinary amounts of oxygen, and its muscles store even more. As it glides beneath the ice, its heartbeat slows, conserving energy while it searches for fish in the blackness. Above, the holes it uses to breathe can refreeze within minutes. The seal keeps them open with its teeth, gnawing through the ice. In these underworld journeys, it moves through a landscape of silence, a cathedral of blue light and slow bubbles. The Weddell seal embodies the balance of grace and endurance, a creature at peace in a realm that would end most lives in moments. Narwhals use their long, spiraled tusks to sense changes in water. The narwhal, sometimes called the unicorn of the sea, swims through Arctic waters with a single spiraled tusk extending from its head. This tusk, an elongated tooth, can reach 3 meters in length and contains millions of nerve endings. It isn't a weapon, but a sensor, capable of detecting subtle changes in temperature, pressure, and salinity. Through it, the narwhal reads its environment like braille, sensing shifts invisible to any eye. Males may also use the tusk in gentle sparring or display, crossing them like lances in slow underwater dances. To encounter a narwhal is to glimpse a legend made real, an animal so strange that early explorers thought it proof of myth. Yet it is perfectly adapted to its icy home, navigating dark fjords beneath shifting ice with quiet intelligence. Its tusk is a story written in ivory, both mystery and meaning, spiraling toward the surface. Greenland sharks may live for over 4 centuries. In the dark, icy waters of the North Atlantic drifts one of Earth's most ancient living creatures, the Greenland shark. It moves slowly, almost dreamlike, through the cold, growing just a few centimeters each year. By studying the chemistry of their eye lenses, formed before birth and never replaced, scientists discovered individuals that may be more than 400 years old. That means some of these sharks were alive before the invention of the telescope, before humans charted much of the globe. They inhabit a world without sunlight for half the year, feeding on fish, seals, and sometimes the remains of whales. Their slow pace is not a weakness but a secret. In the cold, everything slows, even time itself. The Greenland shark reminds us that longevity is not just survival, but the art of moving gently through centuries of silence and sea. Snow petrels nest only on Antarctic cliffs, far inland. Snow petrels are among the most ethereal birds on Earth, pure white, sharp-winged, and hauntingly elegant. They spend most of their lives at sea, skimming the icy waters for fish and krill. But when breeding season comes, they turn toward the continent itself. There, hundreds of kilometers from the ocean, they seek bare rock among the glaciers, cliffs where the wind howls and snow cannot cling. Their nests perch above a world of blue and white emptiness, sometimes hundreds of kilometers inland. They lay a single egg, guarded fiercely against predators and the brutal cold. To reach their nests, they must fly through storms, navigating by instinct and memory. When chicks hatch, they open their eyes to a landscape almost devoid of life, save the echoing cry of their parents. The snow petrel's life is a fragile bridge between sea and sky, beauty and endurance. Entire ecosystems thrive beneath Antarctic ice shelves, cut off for millennia. Far below the frozen roof of the Antarctic ice shelves, where sunlight has not touched the water for thousands of years, life endures. Scientists drilling through hundreds of meters of ice have discovered sponges, worms, and mysterious creatures clinging to the seafloor, thriving in complete darkness. These organisms feed on nutrients carried by slow undercurrents or on traces of material drifting down from the ice above. Some species appear so unusual they may represent entirely new branches of life. Isolated for millennia, These hidden ecosystems have evolved in silence, protected from the chaos of the surface world. They show that life does not require sunlight, only energy and persistence. Beneath Antarctica's vast unmoving ice, there is a quiet pulse of vitality, fragile, secret, and luminous in its resilience. Even here, at the edge of habitability, Earth continues to dream in living forms. Microbes live in liquid lakes, buried under kilometers of Antarctic ice. Deep beneath Antarctica's frozen crust lie hidden lakes, vast bodies of liquid water sealed beneath ice for millions of years. Pressed down by kilometers of ice and kept liquid by geothermal warmth from the Earth below, they remain untouched by wind or weather. When scientists drilled into these subglacial lakes, they found something astonishing: microbial life. These tiny organisms have survived in total darkness, feeding on minerals, hydrogen, and carbon compounds rather than sunlight. Their ecosystems operate in complete isolation, evolving independently of the surface world. To study them is to peer into another kind of Earth, one that mirrors what we might one day find beneath the icy shells of moons like Europa or Enceladus. These buried lakes remind us that life does not just adapt to extremes, it welcomes them, writing new definitions of possibility in every hidden drop of water. Brine channels within sea ice form miniature habitats for algae. Sea ice, though it seems solid, is laced with tiny veins of salty water known as brine channels. Within these frozen labyrinths, microscopic algae bloom, painting the inner walls with shades of gold and green. These miniature habitats are invisible to the naked eye, yet they are the foundation of polar food webs. As sunlight filters through the ice, the algae photosynthesize, feeding zooplankton that drift below, which in turn nourish fish, seals, and whales. When the ice melts in spring, these brine-bound ecosystems spill into the ocean, releasing bursts of life that ripple through the Arctic and Antarctic seas. It is a living paradox, life flourishing inside the very substance that should prevent it. The brine channels reveal a deeper truth of nature. Even in confinement, even in coldest stillness, life finds a way to grow toward the light. Ancient viruses and bacteria lie frozen beneath Arctic permafrost. Beneath the frozen tundra, time stands still. Locked within layers of Arctic permafrost are microscopic relics from ancient ecosystems, bacteria, and viruses that have not stirred for tens of thousands of years. In laboratory conditions, scientists have revived some of these microbes, watching them awaken as if no millennia had passed. They come from eras when mammoths roamed the grasslands and early humans hunted beneath northern skies. Most are harmless, simple survivors of the deep freeze, but their existence raises haunting questions about what else may lie dormant below. The permafrost is both tomb and library, preserving DNA, spores, and cells like pages pressed between sheets of ice. Each thawing layer tells a new story, not just of climate change, but of the resilience of life itself. Even in deep time, Earth never forgets, it merely sleeps, waiting for warmth to call it back. Subglacial Lake Vostok has been sealed off for over 15 million years. Hidden beneath nearly 4 kilometers of Antarctic ice lies Lake Vostok, one of the largest lakes on Earth, yet one that no sunlight has touched for over 15 million years. Its waters remain liquid thanks to the immense pressure of the overlying ice and the faint heat from the planet's core below. When scientists first drilled into the ice above it, they did so with the caution of explorers entering an alien world. The lake's isolation is so complete that any life within it could have evolved along an entirely separate path. Tiny microbial traces found in samples suggest a unique ecosystem adapted to darkness, pressure, and stillness. Lake Vostok is a glimpse into the deep past, a pocket of primordial Earth sealed in ice. It reminds us that our planet still hides worlds within itself, untouched and waiting beneath the frozen veil. Hydrothermal vents beneath Arctic ice sustain life in total darkness. Far below the Arctic Ocean's ice, where sunlight never reaches, the seafloor glows faintly with heat. Here, hydrothermal vents spew mineral-rich water from the Earth's crust, creating an oasis of warmth amid the cold. Around these vents, strange creatures gather: worms without eyes, clams without shells, and bacteria that feed on chemical energy instead of light. They form ecosystems independent of the sun, powered entirely by the chemistry of the deep Earth. The discovery of these vent communities beneath the polar seas reshaped our understanding of life itself. It proved that biology can thrive wherever energy flows, even in perpetual night. The vents hiss softly in the dark, their mineral plumes curling like smoke beneath a ceiling of ice. Above them lies silence, but below, life burns quietly with the heat of the planet's hidden heart. Bright green phytoplankton bloom beneath thinning Arctic ice each summer. Each Arctic summer, when sunlight returns, a strange phenomenon appears beneath the thinning ice. Vast blooms of bright green phytoplankton, glowing like emerald clouds in the dim blue water. Once, the thick ice blocked nearly all light, but as it grows thinner, sunlight now penetrates deep enough to spark photosynthesis. These hidden blooms feed an explosion of life, drawing krill, fish, and whales to feast in the cold seas. Yet they also hint at change. The Arctic is becoming more transparent, more open, and more fragile. Satellites can now see these green veils from orbit, shimmering like ghostly auroras beneath the surface. It is both beautiful and uneasy, the ocean awakening in places once locked in darkness. Life is adapting faster than we can follow, finding new ways to flourish beneath the changing skin of a warming world. The Gambutsev Mountains lie buried beneath Antarctica, tall as the Alps. Beneath thousands of meters of ice in East Antarctica lies a hidden mountain range, the Gambutsev Mountains, unseen and mysterious. Discovered only through radar mapping, they stretch for more than 1,000 kilometers and rise as high as the European Alps. Yet no human eye has ever seen their peaks. Scientists believe they once hosted rivers, valleys, and perhaps forests before being buried under the first Antarctic snows tens of millions of years ago. Now, the ice above acts as both weight and protection, preserving the mountains in a state of ghostly perfection. The Gambutsev Range is a secret Earth keeps from itself, a fossilized landscape frozen mid-breath. To imagine it is to envision a world both lost and eternal, a continent that hides an entire range of mountains beneath another range of time. Antarctica once hosted rainforests. Fossilized stumps still remain. Long before it became a realm of snow and silence, Antarctica was green. Around 19 million years ago, the continent lay farther north, bathed in a milder climate and blanketed in dense rainforest. Fossilized tree stumps and leaves still lie buried beneath the ice, perfectly preserved in sediment. Some contain the cellular structures of wood and even traces of pollen. These relics reveal that the polar world was once humid, alive with ferns, conifers, and flowering plants. Dinosaurs wandered its valleys. Rivers flowed through warm air rich in oxygen. Over millions of years, the continent drifted southward, cooling slowly until forests gave way to ice. The fossils remain like ghosts of forgotten summers, reminders that climate can remake entire worlds. Antarctica's ancient trees are silent now, but they still whisper of warmth and rain in a land where only cold remembers. Dinosaur fossils have been found on both Greenland and Antarctica. Beneath the polar ice, deep in layers of ancient rock, scientists have uncovered bones that once belonged to dinosaurs. On Greenland, fossils of plant-eating giants show that the island once hosted lush forests and meandering rivers. In Antarctica, fossils of small dinosaurs and early birds tell of a warmer, greener world near the South Pole. These discoveries reveal that the polar regions were not always cold. They once teemed with life under long summer days and gentle winters. The shifting of continents and the slow choreography of climate transformed those worlds completely. Now, creatures that once basked in polar sun are entombed in permafrost and stone. Each fossil is a reminder that even the most unchanging landscapes are written in eras, not moments, and that time, more than ice, is the true sculptor of the Earth. The South Pole sits above vast subglacial lakes and hidden rivers. Though the surface of Antarctica seems frozen solid, the land beneath is alive with movement. Beneath the South Pole itself, a network of subglacial lakes and rivers flows silently under the pressure of the ice. The heat from the Earth's core and the friction of glacial motion keep this hidden water from freezing. Using radar and satellite mapping, scientists have traced hundreds of such waterways, connecting vast underground basins across the continent. Some of these rivers carry meltwater toward the sea. Others circulate nutrients that may feed microbial life. The discovery of flowing rivers beneath the coldest place on Earth transformed our understanding of ice sheets. They are not static, but dynamic, breathing systems. The South Pole's hidden rivers remind us that beneath even the stillest surface, motion and mystery continue, unseen but unstoppable, carrying the pulse of an ancient world. Greenland's ice conceals a canyon deeper than the Grand Canyon. Beneath Greenland's ice sheet lies a buried canyon so vast it defies imagination, a hidden chasm stretching for more than 700 kilometers and plunging deeper than the Grand Canyon. Radar mapping revealed its winding path, carved by rivers millions of years before the ice arrived. Though it has been sealed beneath glaciers ever since, scientists believe meltwater still flows through it today, channeling beneath the ice like a secret river. Its discovery revealed that Greenland's landscape is far more dynamic than anyone imagined, a complex system of ridges, valleys, and hidden lakes, all sculpted long before the modern world. The buried canyon is a silent reminder of what lies unseen, a trace of warmth and water locked beneath endless cold. Even under kilometers of ice, the memory of ancient rivers still runs strong. Meteorites are easy to spot in Antarctica's white ice fields. Across the endless white plains of Antarctica, black stones gleam in the sunlight, visitors from space. The continent's dry, frozen surface preserves meteorites perfectly, and the contrast between dark rock and pale ice makes them remarkably easy to find. As glaciers move, they concentrate these fallen fragments in certain areas, creating natural collection zones called meteorite stranding surfaces. Some of these space rocks have drifted across the galaxy for billions of years before landing here. Each one carries chemical clues about the early solar system, the dust of stars, the building blocks of planets. Antarctica acts as both protector and curator, keeping these relics unweathered and pure. For scientists, walking those ice fields is like wandering through a cosmic museum, where every small stone might contain the story of how the universe first began to take shape. Iron-rich polar dust helps fertilize distant oceans. Each year, powerful winds sweep across the frozen continents, lifting fine dust from exposed rock and sending it into the upper atmosphere. Though the source is barren, the dust itself is rich in iron, a key nutrient for marine life. As it settles over the world's oceans, it acts like a fertilizer, sparking blooms of phytoplankton that feed the base of the food chain. From lifeless ice to teeming sea, this invisible connection spans the globe. Even in their stillness, the poles nourish the planet, linking frozen deserts to living waters. It is a quiet exchange, unseen but vital, a reminder that every gust of wind, every drifting particle, is part of an endless circulation of life and renewal. The world breathes as one, from snowfields to surf, through dust born of stone and carried on the breath of the sky. The first humans reached the South Pole in December 1911. In the Antarctic summer of 1911, after months of hardship, exhaustion, and cold, a small group of men finally reached the bottom of the world. Norwegian explorer Roald Amundsen and his team arrived at the South Pole on December 14th, planting their flag in a landscape no human had ever seen. Just weeks later, the British expedition led by Robert Falcon Scott would arrive too, only to perish on their return. The moment marked both triumph and tragedy, a testament to human endurance and the unforgiving nature of the polar world. Their journals describe blinding snow, the strange glow of endless daylight, and a silence so deep it felt eternal. Today, their camps are preserved by the cold, frozen snapshots of courage and ambition. The South Pole stands as both achievement and warning, that exploration often begins with wonder and ends with humility before the ice. Amundsen and Scott led rival expeditions to the South Pole. The race to the South Pole was one of the most dramatic chapters in exploration. Roald Amundsen of Norway and Robert Falcon Scott of Britain set out almost simultaneously, each determined to reach the pole first. Amundsen's team traveled swiftly with sled dogs, guided by polar experience and precision. Scott's relied on man-hauling and experimental machinery that often failed in the brutal cold. Amundsen arrived first, leaving a tent and a letter for Scott to find. When Scott's team reached the pole weeks later, their heartbreak was recorded in stark diary entries beneath a grey Antarctic sky. On their return journey, they succumbed to frostbite, hunger, and exhaustion, just 11 miles from safety. Their story endures not only as a tale of rivalry, but as a meditation on human will, two paths into the unknown, united by the same frozen horizon and the same unrelenting dream. Inuit peoples have thrived for millennia with deep knowledge of ice and wildlife. For thousands of years, Inuit communities have lived across the Arctic's harsh expanses, guided by a profound understanding of their environment. Their survival depends on reading the ice, knowing its colors, sounds, and textures to find safe routes across frozen seas. They can tell the difference between newly formed ice and the deep, ancient sheets that will hold the weight of a sled. Their culture is woven with the rhythms of the land, the migration of whales, the paths of seals, the turning of the seasons. They craft tools from bone and stone, build shelters of snow, and pass down knowledge through story and song. Far from being desolate, their world is rich with meaning, a partnership between people and place. The Inuit remind us that wisdom is not just learned through study, but lived through generations, in harmony with wind, ice, and time. The Vikings reached Greenland and North America through icy northern seas. 1,000 years ago, long before Columbus, Viking explorers sailed through the frigid North Atlantic, guided only by the sun, stars, and memory. Their longships, sleek and strong, cut through icy waters toward unknown lands. Around the year 1000, Leif Erikson reached Greenland and then a new shore they called Vinland, likely part of modern-day North America. These voyages were acts of audacious curiosity, carried out in wooden vessels against cold and storm. Archaeological evidence at sites like Lansall Meadows in Newfoundland confirms their presence, remnants of ironwork and timber still preserved by the northern soil. The Vikings' journeys prove that the polar seas have long connected worlds rather than divided them. Even at the edge of the known world, humanity has always looked outward, drawn onward by the horizon and by the endless whisper of the wind over ice and sea. Early explorers suffered scurvy, frostbite, and starvation in polar expeditions. In the age of wooden ships and wool clothing, the polar regions were places of unimaginable trial. Early explorers set out into seas choked with ice, guided by stars that vanished in months of darkness. They carried only preserved foods and hope, unaware that the lack of fresh fruit and vegetables would soon bring scurvy, a slow, wasting illness that turned muscles weak and gums to dust. Frostbite claimed fingers and toes, while starvation loomed when sled dogs fell or supplies froze solid. Yet they pressed on, driven by wonder and the need to chart what lay beyond the edge of the known world. Their journals speak of pain and beauty intertwined, auroras above, hunger below, and a silence that could unmake a man. The poles demanded everything from those who sought them, and in return, offered glimpses of eternity, painted in ice and endurance. Shackleton's endurance expedition remains a legendary survival story. In 1914, Ernest Shackleton set sail aboard the Endurance, dreaming of crossing Antarctica. But the sea had other plans. The ship became trapped in pack ice, groaning as pressure crushed its wooden hull. For months, the crew drifted helplessly until the ice finally swallowed the vessel whole. Stranded hundreds of miles from land, Shackleton and his men camped on floating ice, surviving on penguins and seals. Eventually, they sailed lifeboats through freezing seas to a barren island, and Shackleton, with 5 companions, ventured onward in an open boat across one of the most dangerous stretches of ocean on Earth. Against all odds, he reached help and returned for his crew. Not a single life was lost. The Endurance became more than a ship. It became a symbol of unbreakable resolve, proof that courage, leadership, and hope can outlast even the Antarctic winter. Early Antarctic huts are still preserved by the cold. Scattered across the icy coastlines of Antarctica stand the wooden huts of early explorers, relics from the heroic age of discovery, preserved by cold and wind. Shackleton's base at Cape Royds still holds jars of food, boats, and handwritten notes, untouched for over a century. At Scott's hut on Ross Island, the air still smells faintly of smoke and seal oil. Nothing decays here bacteria cannot thrive, and wood never rots. Even the fabric of clothing remains soft, as though its owner might return at any moment. Scientists and conservators now tend these fragile time capsules with reverence, knowing they are among the most perfectly preserved historical sites on Earth. To step inside is to feel the breath of ghosts, men who laughed, despaired, and dreamed beneath the howl of Antarctic wind. The ice has kept their world frozen in amber, a century-long whisper of human endurance. The International Geophysical Year of 1957 established permanent research stations. Before the late 1950s, most Antarctic expeditions came and went with the seasons. But during the International Geophysical Year, a worldwide scientific collaboration in 1957 and 58, nations joined forces to study the planet as one living system. Antarctica became a centerpiece. 12 countries established year-round research stations, installing instruments to measure magnetism, seismic waves, and cosmic rays. It marked the dawn of continuous human presence on the continent. From these humble beginnings grew a global network of science, weather monitoring, climate studies, and astrophysics that still thrives today. The spirit of cooperation born in that year shaped how humanity views Antarctica, not as a prize to be claimed, but as a place to understand and protect. The International Geophysical Year turned the world's most remote wilderness into a shared frontier of discovery, uniting nations beneath the same endless sky of ice and aurora. Antarctica is the only continent with no native human population. Every other continent bears traces of ancient footsteps, stone tools, hearths, stories rooted in millennia. But Antarctica has none. No human culture ever arose there, no permanent villages, no ancestral songs. The conditions were simply too harsh, the distances too vast, the cold too absolute. When people finally set foot upon its shores, it was as visitors, explorers, and scientists. Today, thousands live there temporarily in research stations, studying everything from penguins to particle physics. Yet when they leave, the land returns to silence, unclaimed and unchanged. Antarctica remains the world's one uninhabited continent, a blank page at the bottom of the globe, shared by all but owned by none. Its emptiness has its own kind of peace, a reminder that some places still belong only to the Earth itself, untouched by history, speaking in the quiet language of wind and snow. Indigenous Arctic cultures have dozens of words for snow and ice. For the indigenous peoples of the Arctic, snow and ice are not abstractions. They are living landscapes, each form carrying meaning. Their languages contain dozens of words to describe what others might call simply snow. There are words for snow that drifts, that crusts, that softens, that sings underfoot. Words for new ice and for the dangerous thin ice that deceives the unwary. Each term encodes generations of knowledge when it is safe to travel, when seals will surface, when storms are near. These words are maps, stories, and survival tools combined. They reflect a culture of observation so deep that language itself has evolved to mirror the land's subtle moods. To speak these words is to read the Arctic as a living book, one that changes daily yet remains eternal, a conversation between people, snow, and the patient intelligence of the Earth. The Antarctic Treaty of 1959 reserves the continent for science and peace. In 1959, 12 nations signed an agreement unlike any before it. The Antarctic Treaty declared that the entire continent would be dedicated to peace and scientific exploration. No military bases, no weapons, no territorial claims. It was a rare act of unity during the Cold War, an understanding that some places should belong to all humanity. Today, more than 50 nations are part of the treaty, and it continues to protect the world's most pristine wilderness. The agreement forbids mining and preserves the environment, ensuring that the continent remains a natural laboratory and sanctuary. Within its pages lies a hopeful idea that cooperation can exist even in the coldest extremes. The treaty made Antarctica not a prize, but a promise, a living example of what can happen when nations look beyond borders and choose knowledge over conquest. Dozens of nations operate research stations across Antarctica, from the icy coastlines of the Antarctic Peninsula to the lonely heights of the polar plateau. Small clusters of buildings dot the white horizon, the research stations of nations from around the world. Some are permanent, some seasonal, but all exist for the same purpose: to study the planet from its quietest vantage point. Scientists there monitor weather, track glaciers, and study cosmic radiation under skies clearer than anywhere else on Earth. Life at these stations is both communal and isolated. Crews share meals, laughter, and the long silence of polar night. When storms rage, they huddle inside while the wind shakes the walls. From space, the faint lights of these outposts sparkle like stars scattered across the ice. Each one is a testament to human curiosity, proof that even at the edge of the world, we reach outward in search of understanding. South Pole detectors capture ghostly cosmic neutrinos passing through Earth. Beneath the frozen surface of the South Pole, a vast array of sensors is buried deep in the ice. the Ice Cube Neutrino Observatory. It watches for ghostly visitors, neutrinos, tiny subatomic particles that pass through everything, even solid rock, almost without trace. Trillions stream through your body every second, unnoticed. But when one collides with an atom inside the ice, it creates a faint flash of blue light. By tracing those flashes, scientists can map the sources of neutrinos, exploding stars, black holes, and cosmic rays from the edge of the universe. Antarctica's crystal-clear ice makes it the perfect detector, pure and silent as glass. In this way, the South Pole listens to the cosmos itself. Each spark of light beneath the ice is a whisper from distant galaxies, a message that has traveled across eternity to arrive in the heart of the cold. Antarctic radio telescopes study the faint afterglow of the Big Bang. High on the Antarctic plateau, where the air is thin and dry, radio telescopes point toward the oldest light in the universe, the cosmic microwave background, the fading afterglow of the Big Bang. The extreme cold and clarity of the polar atmosphere make it one of the best places on Earth for such observations. Each faint pattern of radiation carries clues about the first moments after creation, when matter, light, and time were just beginning to form. By studying this glow, scientists hope to understand how galaxies arose and why the universe expands the way it does. These telescopes work silently through the long winter night, scanning a sky that never sets. Beneath the auroras, humanity peers backward nearly 14 billion years, using Antarctica's stillness as a window into the dawn of everything. Polar ice sheets record Earth's climate, past and present. The vast ice sheets of Antarctica and Greenland are more than frozen landscapes, they are living archives. Each snowfall compresses into a layer that records the air, temperature, and dust of its time. Over thousands of years, those layers accumulate into histories written in crystal. Scientists drill deep to extract these frozen scrolls, reading them like ancient manuscripts. The ice reveals the rise and fall of greenhouse gases, the timing of ice ages, and the fingerprints of volcanic eruptions. Modern instruments now track how these same sheets are changing, melting, thinning, and flowing faster toward the sea. In their past lies our future, a record of how sensitive the planet is to even small changes in warmth. The ice holds both memory and prophecy, a mirror that shows where we have been and where we may yet go. Antarctica's dry valleys serve as Mars analogues for testing rovers. In a place where wind carves bare rock and no snow falls, Antarctica begins to resemble another world. The McMurdo dry valleys are so cold and arid that scientists use them to simulate conditions on Mars. The soil is sterile, the humidity almost zero, and the landscape painted in shades of red and ochre. Here, robotic rovers and instruments designed for space exploration are tested before being sent to other planets. Even microbial life is scarce, existing only in sheltered rocks and thin films of brine. The valleys remind researchers what extreme truly means, a place where water barely exists, where sunlight burns and freezes simultaneously. Standing there, surrounded by silence and stone, one can almost imagine a future astronaut walking across Martian dust. The dry valleys bridge the distance between worlds, proving that the alien can sometimes be found right here on Earth. The ozone hole was discovered above Antarctica in the 1980s. In the 1980s, scientists studying the Antarctic atmosphere noticed something alarming. Each spring, levels of ozone, the gas that shields Earth from ultraviolet radiation, plummeted. A vast hole had opened high above the continent. The cause was human-made chemicals called chlorofluorocarbons, once used in aerosols and refrigeration. Cold temperatures and polar clouds amplified their destructive effect, tearing the ozone apart. The discovery shocked the world, but also spurred swift action. Nations united to phase out the offending substances through the Montreal Protocol, a landmark environmental agreement. Decades later, satellite data show the ozone slowly healing. The Antarctic sky became both a warning and a symbol of hope, proof that global cooperation can mend what human hands have broken. In the faint blue light of the poles, the atmosphere itself reminds us that our planet is both fragile and forgiving. Satellites track the slow thinning of polar ice from space. From far above Earth, satellites glide in quiet orbits, watching over the poles like patient sentinels. Using radar and laser altimeters, they measure the height and mass of ice sheets with astonishing precision, detecting even changes of a few centimeters. Over decades, these observations have revealed a subtle but relentless truth. The ice is thinning. Glaciers retreat, sea ice shrinks, and meltwater streams carve their way toward the ocean. The satellites record it all, building a time-lapse of planetary transformation. Yet their view is not despairing, it is illuminating. Through their eyes, scientists can model sea level rise, forecast change, and find patterns hidden within the noise of weather. The silent watchers remind us that understanding is the first step toward care. From space, the poles seem delicate and luminous, not remote, but vital threads in the fabric of a living Earth. Antarctic bottom water drives the deep circulation of the world's oceans. At the edge of the Antarctic continent, where icy winds sweep across open sea, a powerful process begins. As surface water freezes, it leaves salt behind, making the remaining liquid denser. This heavy, frigid water sinks to the ocean floor and spreads outward, a deep, slow current known as Antarctic bottom water. It creeps beneath every ocean basin, carrying oxygen and nutrients to the planet's depths, connecting distant seas in one global heartbeat. The cycle takes centuries to complete, yet its influence touches every coastline. Without it, the ocean's lower layers would stagnate. In this way, Antarctica breathes for the world, its cold pulse circulating through the arteries of the sea. It is one of nature's grandest hidden engines, silent, unseen, and essential, turning beneath the ice as steadily as time itself. Polar oceans store immense amounts of carbon from the atmosphere. The seas of the Arctic and Antarctic are more than mirrors of sky. They are vast carbon sinks, drawing invisible gases from the air into their depths. Cold water absorbs carbon dioxide more readily than warm, and microscopic plankton help lock it away by transforming it into organic matter that eventually drifts downward as marine snow. This slow rain of carbon keeps the planet's atmosphere in balance. The polar oceans are therefore key players in regulating climate, though they now face disruption as ice melts and currents shift. Still, even in change, they perform their quiet labor, breathing in what we breathe out. Beneath the glittering flows, chemistry and life conspire in harmony, reminding us that the coldest places on Earth are also among the most vital, quietly protecting the warmth of every living thing. Some of the planet's largest waves form in the Southern Ocean. The Southern Ocean, circling Antarctica, is the wildest sea on Earth. With no continents to block the wind, storms race endlessly around the globe, building waves of staggering height and power. Swells can climb over 20 meters, traveling for thousands of kilometers before breaking. To witness them is to see the raw pulse of the planet, vast rolling walls of water crowned with spray and foam. Satellites and buoys record their movements, helping scientists understand how wind and ocean exchange energy. For sailors, these waters are a proving ground for the world. They are an engine of weather and circulation. The waves of the Southern Ocean are both terrifying and beautiful, reminders that even in a world mapped and measured, there remain forces that answer only to the wind, the moon, and the deep rhythm of the Earth itself. The Southern Ocean circles the globe without touching any continent. The Southern Ocean is unique, a ring of water that flows endlessly around Antarctica, unbroken by land. It is the only ocean that forms a complete loop, its currents weaving together the Atlantic, Pacific, and Indian Oceans in a single, continuous stream. Driven by powerful winds, this Antarctic circumpolar current carries more water than any other, shaping climate patterns across the world. It redistributes heat, mixes nutrients, and connects ecosystems from pole to tropic. Its isolation also creates some of the most extreme weather and some of the cleanest air on Earth. To stand at its edge is to feel the planet turning, the wind unending, the water eternal, circling in ceaseless motion. The Southern Ocean is not just geography, it is the Earth's heartbeat, a cold and constant river encircling the world beneath the gaze of the ice. Antarctic krill swarms can stretch for kilometers and number in billions. In the cold, clear waters surrounding Antarctica, clouds of life drift unseen, swarms of tiny shrimp-like creatures called krill. Each is scarcely larger than a paperclip, yet together they form masses that stretch for kilometers and contain billions of individuals. Krill are the foundation of the Antarctic food web, feeding penguins, seals, whales, and fish. Their nightly migrations, rising to the surface to feed on microscopic algae and sinking by day, churn the ocean and move carbon deep below. From space, their feeding blooms tint the water faint green, a living pulse of abundance. Though small, they embody the paradox of the polar seas, fragile yet immense, invisible yet essential. Without krill, the Southern Ocean would fall silent. Their glittering swarms prove that even the smallest lives can sustain the grandest ecosystems beneath the frozen edge of the world. Bowhead whales in the Arctic can live for 2 centuries. Among the drifting ice of the Arctic, bowhead whales sing in haunting tones that echo through the deep. These giants, with massive skulls built to break through ice, are among the longest-lived mammals on Earth. Some individuals have been found carrying harpoons from the 1800s still embedded in their flesh, silent witnesses to centuries gone by. Their lifespan can exceed 200 years, meaning the oldest alive today were born before electricity lit the world. In that time, they have seen seas change, ice retreat, and ships multiply. Their songs, deep and resonant, may travel for hundreds of kilometers, communicating through a realm few can fathom. To hear a bowhead's call is to listen to history itself, spoken in the language of water and time, a voice from the depths reminding us that patience, not speed, is the true measure of life. Orcas use waves to wash seals off ice floes. In the frozen seas surrounding Antarctica, orcas, also called killer whales, have developed one of the most sophisticated hunting techniques in the animal kingdom. Working together, they line up and charge toward an ice floe carrying a seal, generating a wave powerful enough to wash their prey into the water. The coordination is exquisite. The orcas dive in unison, angle their bodies just right, and strike with a precision learned through generations. Once the seal is in the water, they take turns feeding, each member of the pod sharing in the catch. This behavior shows extraordinary intelligence and social structure, rivaling that of primates. Scientists have even observed orcas teaching their young how to create these waves, passing on knowledge like cultural inheritance. In the stillness of the Antarctic Sea, they are silent strategists, powerful, graceful, and deeply aware of one another. Leopard seals, haunting and sleek, rule Antarctica's icy waters. Gliding through the dark waters beneath the ice, the leopard seal reigns as one of Antarctica's top predators. Its body is long and muscular, its spotted coat a reminder of the cat-like grace for which it's named. With jaws lined in sharp teeth, it hunts penguins, fish, and even other seals. Yet despite their fearsome reputation, leopard seals are curious and intelligent, often approaching divers or inspecting boats with watchful, deliberate eyes. Their underwater calls echo like alien songs, haunting melodies that carry for miles beneath the ice. Each seal's voice is unique, perhaps used to identify individuals across the frozen bays. They spend their lives alone, drifting through a world of endless blue, masters of an ocean too cold for most to survive. In their power and solitude, leopard seals embody the stark majesty of Antarctica itself, beautiful, dangerous, and impossibly alive. Polar stratospheric clouds shimmer with pastel colors during long winter nights. High above the poles during the long winter night, clouds form in air so cold, it seems impossible for vapor to exist. These are polar stratospheric clouds, delicate, iridescent veils that glow with shifting hues of pink, green, and violet. Sunlight scattered from below the horizon catches their icy surfaces, setting them alight like floating mother-of-pearl. Their beauty hides a darker side. These same clouds play a role in depleting the ozone layer, providing a stage for chemical reactions that break ozone apart. Still, to witness them is to see the sky transform into a dream. Against the deep indigo of polar twilight, they ripple and shimmer like auroras made solid. Few sights on Earth are so rare or so fragile, clouds that exist only where the air is cold enough to crystallize color itself. Auroras glow as solar particles collide with Earth's atmosphere. When charged particles from the sun stream toward Earth, our planet's magnetic field guides them toward the poles. There, they strike the upper atmosphere, exciting atoms of oxygen and nitrogen, and the sky comes alive. Curtains of green and violet ripple across the darkness, sometimes crowned with red or blue. These are auroras, the aurora borealis in the north and the aurora australis in the south. Each display is a symphony of physics and light, shaped by invisible solar winds and the Earth's magnetic pulse. From orbit, astronauts can see both auroras at once, mirroring each other across the poles like twin flames. For those on the ground, they are silent, yet they seem to hum with energy, a reminder that even the coldest nights are charged with the breath of the cosmos. No other place on Earth has skies as colorful as the poles. In the polar regions, the atmosphere becomes a canvas for every possible form of light. The sun circles low, painting the sky in endless twilight. Auroras weave green ribbons through the stars. Polar stratospheric clouds shimmer with pearl tones, while diamond dust glitters near the ground. During sunrise and sunset, which can last for hours or even days, the horizon burns with pinks, golds, and violets no artist could reproduce. These skies are alive, responding to the chemistry of ice and the geometry of sunlight. They remind us that color is not just beauty, but physics made visible. Particles scattering, refracting, and glowing in the thin polar air. To stand beneath such a sky is to feel small and infinite at once, watching the planet breathe light into darkness. During polar night, a faint airglow can light the sky. Even in the deepest night of the polar winter, the sky is never completely black. If your eyes adjust and the air is still, you may see a faint, ghostly shimmer, a greenish or reddish haze stretching across the heavens. This is airglow, a phenomenon created when molecules high in the atmosphere release energy absorbed from sunlight hours or even days earlier. Unlike auroras, airglow is constant. Though so delicate, it's easily hidden by moonlight or clouds. In the polar night, however, it becomes visible, turning the sky into a quiet ocean of luminescence. It is Earth's own heartbeat made visible, light born from darkness, a lingering memory of the sun. For those who endure the months of night at the poles, airglow is both comfort and reminder. Even when the world sleeps, energy and life continue above. Sun dogs and halos ring the sun through icy crystals. On clear, freezing days in the polar regions, the sun can appear crowned by light. Bright spots shimmer on either side of it, forming a halo that seems almost supernatural. These sundogs, or parhelia, are created when sunlight passes through countless ice crystals suspended in the air. Each crystal acts like a tiny prism, bending light into rainbows that circle the sky. Sometimes full halos or even double rings form, intersecting arcs of pale fire that stretch across the horizon. Ancient travelers took them as omens, signs from gods or spirits in the frozen heavens. To modern eyes, they remain one of nature's most breathtaking illusions, proof that the atmosphere is alive with hidden geometry. The sky above the poles is rarely empty. It is a cathedral of ice and light, where physics paints miracles before the day's slow-turning sun. Diamond dust sparkles in the air like floating stars. When the air in Antarctica grows impossibly cold and still, tiny ice crystals form directly from vapor, drifting weightless through the sky. This diamond dust sparkles in the sunlight like a field of suspended stars. Each crystal is perfectly shaped, a microscopic snowflake reflecting every hue of the spectrum. Sometimes, they fall so gently that the air seems enchanted, light scattering in halos around every shadow. Pilots flying through diamond dust describe it as flying through light itself, an experience both eerie and serene. These crystals form only in the purest cold, when the atmosphere is too dry for clouds, yet too frigid for emptiness. They are the breath of the ice turned visible, a glittering reminder that even in silence, the air above the poles is alive with structure, symmetry, and wonder. The Arctic is warming 4 times faster than the global average. Nowhere on Earth is climate change more visible than in the Arctic. Over the past decades, temperatures there have risen 4 times faster than the planet's average. Sea ice that once lasted all year now melts each summer, glaciers retreat, and permafrost thaws, releasing ancient gases trapped for millennia. This phenomenon, called Arctic amplification, occurs because melting ice exposes darker ocean and land beneath, which absorb more sunlight and trap more heat. The cycle feeds upon itself, accelerating change. Scientists studying the region describe it as a planetary early warning system. What happens in the Arctic foreshadows the future elsewhere. Yet even amid this transformation, life persists. Mosses greening new tundra, birds adapting their migrations, people finding ways to endure. The Arctic reminds us that beauty and urgency can coexist, that every degree of warmth ripples across the world. Thwaites Glacier, the Doomsday Glacier, could raise sea levels worldwide. On the western edge of Antarctica lies Thwaites Glacier, a mass of ice the size of a country, flowing toward the Amundsen Sea. Scientists call it the Doomsday Glacier because of its potential to reshape the planet's coastlines. If it collapses entirely, it could raise global sea levels by more than 0.5 meters, and its loss could destabilize neighboring glaciers, multiplying that effect. Beneath it, warm ocean currents gnaw at the ice from below, carving vast voids and thinning its foundations. Satellites have captured its retreat, accelerating year after year. Yet even as it melts, the glacier moves with the grandeur of a slow-motion cataclysm, silent, colossal, inevitable. Its fate is a mirror held up to humanity's choices. Watching Thwaites is like watching time itself fracture. an ancient frozen river beginning to awaken beneath the heat of a changing world. Polar bears now swim longer distances as sea ice vanishes. Polar bears once traveled easily across the frozen Arctic, using the sea ice as hunting ground and highway. But as the ice retreats earlier each summer and reforms later each winter, they are forced to swim farther between flows, sometimes for days. Mothers with cubs have been seen crossing open stretches of ocean more than 100 kilometers wide, battling exhaustion and cold. Some never make it. The bears depend on seals that rest on the ice, but as their platform melts, their food grows scarce. Scientists track them with satellite collars, watching patterns of survival shift with each passing year. And yet, they endure, fierce, solitary wanderers, adapting to a vanishing world. The image of a bear adrift on melting ice is more than a symbol, it is a truth, both beautiful and heartbreaking, written across the mirror of the Arctic Sea. Melting Arctic permafrost releases methane into the atmosphere. Beneath the Arctic tundra lies frozen ground that has remained locked for tens of thousands of years. This permafrost contains immense stores of carbon, ancient plant matter preserved in ice. As the Arctic warms, that permafrost begins to thaw, awakening microbes that release methane, a greenhouse gas far more potent than carbon dioxide. Plumes of methane bubble from lakes and wetlands, invisible to the eye, yet measurable from space. Scientists call it a feedback loop. Warming causes thawing, and thawing causes more warming. Some describe it as the Earth exhaling its ancient breath. The process is slow but relentless, altering not just the Arctic, but the entire planet's balance. In the still air of the far north, the ground itself is stirring, a reminder that even frozen landscapes are never truly asleep. Some penguin colonies in Antarctica are rapidly shrinking. On the icy shores of Antarctica, colonies of Adelie and chinstrap penguins once numbered in the hundreds of thousands. But as sea ice patterns change and krill, their main food source, decline, many of these colonies are dwindling. Scientists return each season to count the birds and find empty nesting sites where generations once thrived. Some species are shifting southward in search of colder, more stable ice. Others adapt by changing diets, feeding on fish instead of krill. The transformation is quiet but profound, a living record of climate written in feathers and stone nests. Yet amid loss, there is resilience. Emperor penguins still gather in the depths of winter, their huddles glowing with shared warmth beneath the aurora. The story of Antarctic penguins is both elegy and hope, a lesson in endurance at the edge of the world. Ice shelves can collapse suddenly, releasing vast icebergs. To the human eye, an ice shelf seems eternal, a shimmering plain stretching to the horizon. But beneath its calm surface, stresses build silently. Cracks form and deepen over years. Then, one day, the structure gives way. In hours, a slab of ice the size of a small country can break free, fracturing into icebergs that drift into the sea. Satellites have recorded these collapses, such as the sudden disintegration of the Larsen B ice shelf in 2002, an event that shocked scientists and changed our understanding of ice dynamics. The sound of such a collapse is said to resemble thunder rolling from every direction at once. These events remind us that even the most ancient ice is not still. It lives, moves, and occasionally dies in moments of magnificent violence, reshaping coastlines and rewriting maps. Indigenous Arctic communities face threats from changing ice and seasons. For thousands of years, indigenous peoples across the Arctic, Inuit, Sami, Chukchi, and many others, have lived in harmony with the rhythms of ice and sky. But now, those rhythms are changing. Sea ice forms later, melts earlier, and migratory animals follow new patterns. Traditional hunting routes become treacherous as once stable ice thims. Thawing permafrost damages homes and sacred lands, while erosion eats away at coastal villages. Yet these communities hold immense knowledge, passed through generations, reading winds, stars, and snow to survive where few others could. Many are now combining ancestral wisdom with modern science to adapt. Their resilience is as deep as the Arctic itself, rooted, flexible, and wise. As the world looks north for answers, indigenous voices remind us that the future of the Arctic is inseparable from the people who have always called it home. Retreating Greenland glaciers reveal new islands and fjords. As Greenland's glaciers shrink, their retreat uncovers hidden landscapes that have not seen sunlight for thousands of years. New fjords emerge, stretching inland where ice once lay thick, and isolated ridges become islands in the melting flow. Scientists map these freshly revealed features using satellites and ships, documenting the birth of coastlines in real time. The process is breathtaking and bittersweet, creation through loss. Where ice walls once towered, waterfalls now plunge into green-blue seas. Each new island is both discovery and warning, evidence of a world in transition. In their meltwater flows the story of Earth's changing climate, carving paths that lead from ancient ice into an uncertain future. To stand before a glacier's retreat is to witness geology sped up to human time, the planet rewriting its own edges, line by line. Arctic mosquitoes can swarm so thickly they form living clouds. Summer in the Arctic brings not only light and thaw, but a living storm of mosquitoes. As tundra ponds and melting snow create temporary wetlands, countless larvae hatch in synchrony, rising into the air in dense, humming clouds. These swarms can be so thick that caribou stampede to escape them, and researchers must wear netted hoods just to breathe. The insects thrive in the brief warmth, reproducing with furious speed before the next freeze arrives. Despite their nuisance, they are vital to the ecosystem, food for migratory birds and fish, part of the seasonal pulse that sustains Arctic life. In the glow of endless daylight, their wings catch the sun, turning the air into a shimmering haze of motion. Even in the land of ice, life finds a way to fill every fleeting moment of warmth. Blood Falls in Antarctica pours red, iron-rich water from beneath the ice. At the edge of Taylor Glacier in Antarctica, a strange waterfall stains the ice with crimson. Known as Blood Falls, it is not made of blood, but of briny water rich in iron and oxidized by air. Trapped beneath the glacier for nearly 2 million years, this salty, oxygen-poor liquid carries microbial life that survives without sunlight. When it seeps through cracks and meets the air, the iron rusts, painting the ice with eerie red streaks. Scientists studying blood falls are uncovering clues about how life might exist on icy moons like Europa or Enceladus. Beneath its surreal beauty lies a living chemistry older than human history, a message written in rust and ice that even in darkness, life persists. The glacier bleeds, but what flows from it is not death. It is endurance, hidden and ancient. Antarctic fish produce antifreeze proteins to survive freezing seas. In the sub-zero waters around Antarctica, most fish would freeze solid in minutes. Yet many species thrive there, thanks to a remarkable adaptation: antifreeze proteins circulating in their blood. These molecules prevent ice crystals from forming inside their bodies, allowing them to swim in water colder than their own freezing point. Among the most extraordinary are the ice fish, whose blood is clear, lacking hemoglobin entirely. Scientists believe these adaptations evolved millions of years ago as the Southern Ocean cooled. Today, Researchers study these proteins to inspire cryogenics and medicine, hoping to preserve human cells as nature preserves these fish. To see them gliding under the ice, translucent and slow-moving, is to glimpse evolution's quiet genius. Life rewriting its chemistry to survive in a world made of cold. Frost flowers bloom like delicate crystals across new sea ice. When calm air meets freshly frozen sea, the surface becomes a garden of frost flowers, fragile ice formations that sprout in clusters, each one unique. They form when warm vapor rises from the sea and crystallizes instantly in the cold, creating intricate branching patterns that sparkle in morning light. Under a microscope, each flower is a masterpiece of geometry, fleeting and impossibly detailed. Scientists have discovered that frost flowers are not just beautiful, they are also laboratories of chemistry, concentrating salt and organic compounds from the sea below. As they evaporate or are swept away by wind, they release these elements back into the air, influencing the Arctic's delicate balance. For a few hours before the wind erases them, the ice becomes a frozen meadow, a quiet crystalline bloom at the edge of the world. Shifting ice flows can groan and thunder across the ocean. The Arctic Ocean is never truly still. Its surface is a mosaic of drifting flows that press and scrape against one another, pushed by wind and current. When two masses of ice collide, the sound can be startling. A deep groan, a crack like a gunshot, or a rolling thunder that travels for kilometers. These noises are the voice of a living landscape, the ice flexing, fracturing, and healing as temperatures shift. At times, the pressure builds so high that sheets of ice buckle upward into ridges taller than houses. Sailors of the old polar expeditions described lying awake at night, listening to the frozen sea roaring beneath them. Today, satellites and underwater microphones record the same song, a symphony of stress and movement. Beneath that haunting soundscape, the Arctic continues its endless slow dance between solid and liquid, silence and sound, night and day. Brinicles, icy fingers of death, freeze everything they touch. Deep beneath the Antarctic sea ice, a strange and deadly phenomenon forms when dense, supercooled brine spills downward into the ocean. As it sinks, it freezes the surrounding seawater into a hollow, twisting tube of ice. A brinicle, sometimes called an icy finger of death. Moving slowly but inexorably toward the seafloor, it freezes everything in its path: starfish, urchins, and other creatures too slow to escape. Time-lapse footage shows these ghostly fingers curling like underwater stalactites, glinting pale blue in the dim light. They can take hours to form and minutes to destroy. Brinicles reveal how dynamic and lethal the under-ice world can be, a place where beauty and danger coexist. To witness one is to see physics and art entwined, salt, temperature, and motion weaving a spell that turns liquid into sculpture, life into stillness, and the ocean into a frozen dream. Polar mirages can make icebergs look like floating castles. In the extreme cold of the polar regions, the air bends light in strange ways. Layers of warm and cold air refract sunlight, creating towering illusions that shimmer above the horizon. Sailors have long called these fata morgana, mirages so vivid that distant icebergs appear to rise into the sky as floating fortresses, cliffs, or even ships. Sometimes the images stack upon themselves, forming shapes that pulse and transform as the air shifts. Explorers once mistook them for new lands, chasing them across the ice. Today we understand the science behind the spectacle, temperature gradients bending light into magic. Yet even knowing this, the sight is no less wondrous. The polar air is a lens and a painter, reshaping reality itself. In a landscape already surreal, mirages remind us how thin the line can be between the real and the imagined, between ice and illusion. Winter river ice in the Arctic can crack with explosive booms. When deep cold grips the Arctic, rivers freeze solid, but ice is never perfectly still. As temperatures swing, the ice expands and contracts, building tension across its surface. Suddenly, it releases. The sound echoes through the valley like a cannon blast or rolling thunder. Locals describe the ground trembling as frozen sheets crack apart, creating new pressure ridges and open leads. These booming fractures can travel for kilometers, one sharp crack triggering another in a chain reaction of sound. Sometimes, air trapped beneath the ice escapes all at once, adding a hollow roar that startles even seasoned Arctic residents. In the silence of midwinter, these sounds feel almost alive, as though the river itself was sighing under the weight of the cold. Nature, even frozen, is never still, always flexing, shifting, and speaking in the deep, resonant voice of ice under stress. Lake Untersee's alkaline waters produce rare methane from microbes. Hidden deep within East Antarctica lies Lake Untersee, one of the strangest bodies of water on Earth. Its surface remains sealed beneath ice, but below that lid is a world of extremes. Water so alkaline it rivals ammonia, fed by microbial colonies that have thrived without sunlight for millennia. These microorganisms release methane in steady streams of bubbles, forming vast underwater mats of carbonate and slime that resemble alien reefs. Scientists believe they may hold clues to early Earth, or even to life on other planets. The lake's chemistry mirrors what might exist beneath the icy crust of moons like Europa. To sample it requires drilling through thick, ancient ice, lowering instruments into an environment untouched by the surface world. Down there, in a darkness unbroken for thousands of years, life endures, small, patient, and utterly extraordinary. Antarctic snow can appear pink or green from blooming algae. Across the white expanse of Antarctica, patches of snow sometimes blush with color, streaks of pink, orange, or even green. The cause is microscopic, cold-loving algae that bloom when sunlight and meltwater return in summer. These tiny organisms contain pigments that protect them from ultraviolet radiation, tinting the snow around them. Though beautiful, the blooms have a surprising effect on the planet's climate. Darker snow absorbs more heat, accelerating melting and altering local temperatures. Scientists call it a feedback of color. Yet these snow algae are also a marvel of endurance, living where nearly nothing else can. They photosynthesize in freezing water, reproduce in ice, and vanish again when winter returns. To see them is to realize that even Antarctica, a place of silence and desolation, is alive at the smallest scales, its snowfields blooming softly under the midnight sun. The polar regions offer some of the clearest skies on Earth. Far from pollution and moisture, the air over the poles is astonishingly pure. In winter, when the sun disappears and temperatures plummet, the sky becomes a window into the cosmos. There is little dust, little turbulence, just crystalline stillness. At observatories like those on the Antarctic plateau, scientists can observe faint signals that are blurred or hidden elsewhere. Even the stars seem sharper, their light barely twinkling. During calm nights, the atmosphere is so transparent that distant planets and the Milky Way appear with startling clarity. For astronomers, it is paradise. For anyone else, it is a reminder of scale. Beneath those flawless skies, the Earth feels both immense and small, a glowing sphere adrift in space, breathing quietly beneath an endless sea of stars. In polar night, stars circle the horizon without rising or setting. During the long months of polar night, when the sun never climbs above the horizon, the sky performs a slow and beautiful motion. Stars do not rise or set. Instead, they circle endlessly around a single point, the celestial pole. To those who live and work in the high latitudes, this motion becomes hypnotic, a nightly clock that measures time without light. The constellations trace gentle spirals, Orion tipping sideways, the Southern Cross wheeling low and patient. With no dawn to divide the days, time stretches and folds, and the world feels suspended. In this endless twilight, one understands why ancient people imagined the heavens as a turning dome, steady, eternal, and profoundly calm. Even the darkness has rhythm here, and in the cold, still air, the stars seem close enough to touch. At the South Pole, the sun rises and sets only once per year. The rhythm of day and night at the South Pole follows a pattern unlike anywhere else on Earth. Each year, the sun rises once in September and circles the horizon for months, climbing higher each day. Then, in March, it dips lower and lower until it sets, plunging the pole into 6 months of unbroken night. During that darkness, temperatures drop below -70 degrees Celsius, and the world glows only by starlight and aurora. For the small teams who overwinter at the Amundsen Scott Station, the year's single sunset feels monumental, a marker of courage and patience. When the sun finally returns, it rises not as a dawn, but as a resurrection. At the South Pole, time moves in vast luminous arcs, reminding humanity that our days are measured by the tilt of the spinning world. Earth's tilt, which creates seasons, is felt most dramatically at the poles. The reason Earth has seasons is simple but profound. The planet's axis is tilted about 23.5 degrees. Nowhere is that tilt more powerfully expressed than at the poles. For half the year, one pole leans toward the sun, basking in continuous daylight, while the other leans away, lost in endless night. Then, the balance reverses. The poles are like metronomes for the planet's rhythm, light and dark, warmth and cold, cycling in cosmic precision. This tilt shapes everything: migration, weather, climate, and even the evolution of life. Without it, the poles would not freeze, the tropics would not flourish, and the world would be eerily uniform. Instead, Earth's gentle lean gives us contrast and change, the poetry of time written in sunlight and shadow, expressed most purely at the frozen edges of the world. Astronauts train for isolation in Antarctic research bases. The silence of Antarctica is unlike any other on Earth, vast, unbroken, absolute. For this reason, space agencies send astronauts there to prepare for life beyond the planet. The isolation, the cold, the confinement, and the need for self-sufficiency all mirror conditions they will face on the Moon or Mars. Inside research bases, crews practice teamwork through the long polar night, when darkness and monotony test the mind. Outside, they learn to work in bulky suits, navigate in whiteouts, and handle equipment in sub-zero temperatures. The environment becomes both teacher and mirror, showing them what endurance truly means. In this frozen desert, they discover that space is not only above us, it is also within us, found in the quiet places where humanity meets the unknown with courage, curiosity, and calm. The pole's extreme cold makes them ideal for testing space technology. Spacecraft and instruments must survive freezing voids, harsh radiation, and sudden extremes, and the polar regions offer an earthbound preview. Engineers test rovers, sensors, and habitats in Antarctica's brutal conditions to ensure they can function on Mars or icy moons. Batteries, solar panels, and communication systems all behave differently in deep cold here. Failure is informative. The endless daylight of polar summer provides another advantage. simulating the illumination astronauts might encounter on other worlds. Even the icy terrain helps. Traction, drilling, and dust resistance can all be tested on frozen ground. Beneath the auroras, the Earth itself becomes a laboratory for exploration beyond it. The same cold that challenges life on this planet helps humanity prepare to find it elsewhere. Proof that discovery often begins in the harshest and quietest corners of home. The Antarctic Peninsula is one of the fastest warming places on Earth. Over the past half-century, the narrow spine of the Antarctic Peninsula has warmed by several degrees, one of the sharpest increases anywhere on the planet. Glaciers that once reached the sea have retreated, and ice shelves that stood for millennia have broken apart. Mosses now creep across bare rock, and Gentoo penguins expand their range southward. Scientists stationed there have witnessed the transformation firsthand, measuring its pace year by year. The warming of the peninsula is both a warning and a revelation. Even the coldest places are not beyond reach of human influence. Yet in that change lies knowledge. By studying it, we learn how Earth's systems respond, adapt, and sometimes recover. The peninsula's thawing cliffs are pages in a story still being written, a reminder that climate is not abstract, but alive, shifting beneath the southern sun. Greenland loses hundreds of billions of tons of ice each year. Each summer, Greenland's ice sheet sheds unimaginable volumes of meltwater, hundreds of billions of tons flowing toward the sea. Streams carve blue veins across its surface, merging into vast rivers that vanish down moulins, tunnels leading deep into the ice. From space, this melt appears as shimmering lakes that form and drain within days. Scientists studying the island have found that the pace of loss is accelerating, contributing significantly to global sea level rise. Yet within this transformation lies a complex balance of natural cycles and human-driven warming. Greenland's ice is ancient, snow compacted over 100,000 years, and its retreat unfolds like a slow-motion revelation. Every drop that escapes carries memory of storms, of time, of atmosphere. To watch Greenland melt is to watch history itself flow away, clear and cold and unstoppable. Antarctica is nearly 1.5 times larger than the United States. Antarctica's scale is almost beyond imagination. Spanning over 14 million square kilometers, it is nearly 1.5 times larger than the United States and holds about 70% of the planet's fresh water. Its mountains rise higher than the Alps, and its ice shelves stretch farther than many countries. Yet most of it remains unseen, hidden beneath kilometers of ice. This vastness creates its own weather, its own silence. Standing anywhere on the continent, the horizon curves visibly, and the world feels emptied of all but sky and snow. Scientists often describe the sensation as standing at the edge of the Earth. In truth, Antarctica is not an edge, but a foundation, a frozen heart that balances the planet's climate, reflecting sunlight and storing the breath of centuries within its endless white expanse. The Arctic Ocean is the smallest and shallowest ocean on Earth. Encircled by continents, the Arctic Ocean is the smallest and most enclosed of the world's seas, yet it is also among the most dynamic. Much of its surface is covered in shifting ice that expands each winter and recedes in summer, revealing a patchwork of water and flow. Its average depth is just over 1,000 meters, making it the shallowest ocean on Earth. But beneath its surface lies a complex web of currents that connect it to the Atlantic and Pacific. These waters regulate global climate and nurture life in staggering abundance. Plankton blooms, fish schools, seals, whales, and migratory birds. It is an ocean defined by rhythm rather than size, a breathing, circulating world that proves greatness is not measured in scale, but in the quiet persistence of its pulse. The Ross Ice Shelf is larger than the entire country of France. The Ross Ice Shelf, a floating slab of glacier ice attached to Antarctica's coast, is so vast it defies perspective. Covering more than 500,000 square kilometers, larger than France, it forms a barrier between land ice and the open sea. Its towering cliffs of frozen blue rise nearly 50 meters above the water, with hundreds more hidden below. The shelf moves slowly, creeping outward as glaciers feed it from behind. Eventually, great sections break away, birthing icebergs that drift for decades across the Southern Ocean. Scientists monitor the Ross Ice Shelf carefully, for its stability influences global sea levels. Yet to gaze upon it is to feel awe rather than fear. A continent-sized sculpture of light and pressure, moving imperceptibly, shaped by gravity and time, into one of the grandest structures on Earth. Mount Erebus, the world's southernmost volcano, erupts continuously. Amid Antarctica's endless ice, one mountain burns. Mount Erebus rises from Ross Island, its summit wreathed in steam and fire. It is the world's southernmost active volcano, and one of the few with a persistent lava lake glowing within its crater. Scientists who climb its slopes describe the surreal contrast: blizzards raging against molten rock, snow hissing into vapor. Erebus has erupted for centuries, sometimes hurling molten lava bombs skyward that freeze mid-air before landing. The mountain's constant activity offers a glimpse into the Earth's inner heat, reminding us that beneath even the coldest regions, the planet's heart still beats with molten rhythm. To stand there is to witness both creation and destruction, the meeting of fire and ice, where opposites fuse into one eternal act of transformation. The magnetic North Pole drifts across the Arctic each year. The magnetic North Pole, the point toward which compasses are lean, is not fixed. It wanders, slowly but steadily, across the Arctic Ocean. For centuries it lay within Canada, but it has been drifting toward Siberia at a pace of dozens of kilometers each year. The movement is driven by shifting flows of molten metal deep within Earth's outer core, where the planet's magnetic field is generated. Satellites and explorers track its path, updating maps and navigation systems as it moves. This drift is a reminder that even the invisible forces we take for granted are dynamic. The planet beneath our feet and the magnetism that guides our tools is alive with motion. The North Pole's wandering path is both mystery and metaphor, a silent migration within the Earth itself. The South Pole is marked by a ceremonial pillar surrounded by treaty flags. At the geographic South Pole, where every direction leads north, a small silver sphere rests atop a striped red and white post. Around it fly the flags of the nations that signed the Antarctic Treaty, symbols of peace at the end of the Earth. Nearby, the actual scientific marker, which shifts each year as the ice slowly moves, is recalibrated with quiet ceremony. Visitors often photograph themselves beside the pillar, bundled in layers, the sun circling low above an endless horizon of white. There is no sound but the wind. In that stillness, the monument feels almost spiritual, a human gesture of unity in a place too vast to claim. The South Pole stands not as a conquest, but as a reminder that exploration can also be an act of reverence for the planet we share. The poles fade now into silence. The wind softens, the stars hang steady, and the frozen seas lie still beneath their endless sky. You've traveled through light and shadow, through auroras and ice, through the breath of glaciers and the hush of drifting snow. In these remote corners of the world, time loosens its grip. Every sound seems older, every motion slower, as though the planet itself is breathing in its sleep. Here, life endures in quiet defiance. The ice remembers, the oceans listen, and the sky holds a million secrets still unspoken. And as the last flicker of polar light fades from your thoughts, all that remains is calm, the kind that reaches deep and stays. If you enjoyed this journey, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. For now, just breathe. Let your mind drift, and let the world's cold edges cradle you in peace, vast, ancient, and beautifully still. Good night.